Hello, this is Sujit. Welcome to Physics 2020. Today we are going to discuss the problems of relative velocity. Okay, in the previous section we have discussed the concepts of relative velocity. So what are the things we have seen? What is relative motion? What is frame of reference? What is the role of frame of reference in relative motion? And we have seen that is what is relative velocity, the definition for relative velocity. We have derived the expression for relative velocity, and also we have discussed some of the special cases in relative velocity. Okay, so in this section we are going to discuss the 5 problems in relative velocity. Actually I have the plan to solve 10 problems in relative velocity. So in order to reduce the duration of the video, that is I have split it into 2 parts, the first 5 problems in this section and another 5 problems in the next section. So after completing that session, the next session with the 5 problems, we will wind up this chapter, that is motion in a straight line. So after that I will start the second chapter, that is motion in a plane with vectors. Okay, fine. So the problems of relative velocity. So first of all, suppose A is an object, okay, which is moving with the velocity v ag. Okay, that is velocity of A with respect to ground, and B is an object which is moving with the velocity Vb with respect to ground. So then what we have seen, that is the velocity of A with respect to B is equal to velocity of A minus velocity of Ag minus velocity of B with respect to ground. So normally we will consider ground as the frame of reference. Okay, so Vag, that is velocity of the object A with respect to ground, velocity of the object B with respect to ground. Then velocity of A with respect to B, or velocity of A as seen by B, or velocity of the relative velocity of A with respect to B. So Vag minus Vbg. So similarly velocity of B with respect to A is equal to Vbg minus Vag. So this is the 2 formulas you have to keep in mind for solving the problems of relative velocity. And also the sign convention also. Sign convention, that is, suppose this is the origin, okay, origin. So the objects, the velocity of the objects which is going in the rightward direction is taken as positive, and the velocity of the objects which is going in the leftward direction is taken as negative. So this is the sign convention we are using for solving the problems. So these are the things you have to keep in mind for solving the problems, that is velocity of A with respect to B, similarly velocity of B with respect to A, and also the sign conventions. Okay. First problem. So consider the situation. Consider the situation. This is the road. So a car is moving with the velocity 10 meter per second. So inside the car a person is there, that is A. Another person B is standing on the road. Okay, road. So find the velocity of A with respect to B. Find the velocity of A with respect to B. So from this diagram what we can write, that is solution. So from this diagram, that is velocity of A with respect to ground is equal to 10 meter per second. Velocity of B with respect to ground is equal to 0 meter per second. Okay. So V A B, that is velocity of A with respect to B, is equal to formula velocity of A with respect to ground minus velocity of B with respect to ground. So that's equal to 10 minus 0, that's equal to 10 meter per second. So actually what is the feeling? So a person, suppose I am the observer, I am standing on the road, another person A is traveling in the car which is moving with 10 meter per second. So when I am watching, that is a person is moving with, that is I have the feel, that is the person is moving with 10 meter per second. So that is velocity of A with respect to me, so with respect to the observer. So what I feel, that is I am standing in the road. So another person B is person is standing traveling in the car with 10 meter per second. So when I watch him, so what I feel, that is the person is moving with 10 meter per second. So that's why velocity of A with respect to B. Okay, so 10 meter per second. So consider the situation. So B. So find the velocity of A with respect to B. So in this case, both the persons A and B is inside the car and they are moving with 10 meter per second. So we have to find the velocity of A with respect to B. So solution. So V A G. So when we have seen from the ground frame, okay, ground frame, VAG is equal to velocity of A with respect to the ground reference. So A is moving with, that is 10 meter per second. So velocity of B with respect to ground. So normally we will consider that if the ground as the frame of reference, okay, ground as the frame of reference. So VBG is equal to, that is 10 meter per second. So when we observe from the ground, so both the person A and B is moving with 10 meter per second. So we have to find velocity of A with respect to B. So VAB is equal to VAG minus VBG. Okay, so that's equal to 10 minus 10, that's equal to 0 meter per second. So what is the field? Suppose in the car a person is there, so A. So suppose I am the observer inside the car. So both the persons are sitting inside the car. So I and that person is sitting inside the car. So when I observe that person, so what we will feel? That is inside the car and I am watching that person. So what I feel, that is he is at rest only. So when the car is observed from, or the two persons are observed from the ground, so they are moving with 10 meter per second. Suppose I get inside the car, so initially I am in the road, okay, the observer, I am in the road and I am watching that person, he is moving with 10 meter per second. I get inside the car and sitting near him and I am watching that person. what I feel? He is at rest only. He is not moving. Inside the car, he is not moving. So the velocity of that person with respect to me is 0. So that's why 0 meter per second. Clear? So second problem. So a car which is moving with 10 meter per second ahead of another car B which is moving with 6 meter per second. So find the velocity of A. Find the velocity of A with respect to B and vice versa. Okay, and vice versa. Find the velocity of A with respect to B and vice versa. Vice versa means velocity of B with respect to A. Okay. So solution. So from the diagram we can write that is velocity of A with respect to ground. When the car is absorbed from the ground, so it is moving with 10 meter per second. Velocity of B with respect to ground is equal to 6 meter per second. So first we have to find velocity of A with respect to B. Velocity of A with respect to B is equal to velocity of A with respect to ground minus velocity of B with respect to ground. So velocity of A with respect to ground, that is 10 minus 6. So that's equal to plus 4 meter per second. So what is the field? So velocity of A with respect to B. Velocity of A with respect to B. So B is the observer. Okay, so the observer is on the car B. Okay, car B. So when an observer in the car B is watching the car A, so what is his feel? So he feels that the car A is moving, so in the positive direction, positive plus 4 meter per second. Plus 4 meter per second means the car A is moving in the forward direction. In the forward direction with the speed of 4 meter per second. Actually, according to the ground frame. So now when an observer is in the ground and when he observes the car A, so he feels that the car is moving with 10 meter per second. When the observer is on the car B and he observes the car A, so he feels that the car A is moving in the forward direction with the speed of 4 meter per second. Okay. So vice versa. Vice versa means we have to find velocity of B with respect to A. Okay, velocity of B with respect to A. So velocity of B with respect to A. Formula: velocity of B with respect to ground minus velocity of A with respect to ground. Okay, so that's equal to velocity of B, that is 6, minus that is 10. So that's equal to minus 4 meter per second. Okay, 6 minus 6 minus 10, that's equal to minus 4 meter per second. So now velocity of B as seen by A. So A is the observer. Okay, A is the observer. So suppose the observer is on the car A and when he turns back, so what is his feel? The car B is moving in the backward direction because minus means the car is moving in the backward direction. So for a ground frame, so suppose the observer is in the ground, okay, ground, and he is watching the car B. The car B is moving in the forward direction with the speed of 10 meter per second. When the observer gets inside the car and he is watching back, that is, he is watching the car, he feels that the car B is moving in the backward direction, okay, backward direction at the rate of 4 meter per second. That is the feeling. So try to understand that feeling, that is when the observer changes the frame of reference from ground to the next frame. That is very, very important. Okay, so minus 4 meter per second. Clear? So third problem. So consider the situation. Consider the situation. Okay, a car A is moving with 2 meter per second ahead of another car B, which is moving with 8 meter per second. Okay, when these two cars are 24 meter apart, okay, 24 meter apart. So find the time. So we have to find the time B overtakes A. So when these two cars are 24 meter apart, so we have to find the time B overtakes A. So we are going to solve this problem in a normal method, that is we have studied, that is using the relation of distance, velocity and time. So we can solve this problem. So after that we will solve the problem using relative velocity concept. Okay, so yes, after we are considering after time t, okay, after time t the car B overtakes A. So we are considering after time t the car B overtakes the car A. So we can say that yes, A. So when the time of overtakes, the two cars are in this position, okay, B, right? So after time t, let XA be the position of the car. XA be the position of the car. XA be the position of the car, and X be the position of the car, or XA the distance travelled by the car after time t, and X be the distance travelled by the car B after time t. Okay, so from this we can write, that is XB is equal to this 24 plus XA. So XB is the total distance. So XB is equal to, we can write XA plus 24. Am I right? So XA plus 24. Okay, so we know the relation, that is a distance in terms of velocity and time. So velocity is equal to distance by time. So distance equal to velocity into time. Am I right? Velocity into time. So the car B is moving with the velocity that is 10 meter per second. So it covered the distance xb after time t. So 8t is equal to the car, that is the car A is moving with the velocity 2 meter per second. So therefore 2t plus 24. So 2t, 8t minus 2t, that is 60 is equal to 24. So t is equal to 24 by 6, that's equal to 4 seconds. 4 seconds. So that is the answer. So what we consider initially, after time t, the car B overtakes the car A. So t is equal to 4 seconds. So after time 4 seconds, the car B overtakes the car A. Okay. So this is we have solved this, that is using the relation of, that is velocity, the velocity, displacement and time. Now we are going to solve this problem using relative velocity concept. Okay, relative velocity concept. So from this velocity of A with respect to ground, okay, is equal to 2 meter per second. Velocity of B with respect to ground, velocity of B with respect to ground, that's equal to 8 meter per second. 8 meter per second. So I am finding, that is velocity of A as seen by B. Velocity of A as seen by B. So that means A is the observer. Okay, A is the observer. That is at rest. Am I right? Rest. This car is at rest. So A is the observer. The observer is in the car A and he is watching the car B. So that is velocity of A with respect to B. So sorry, velocity of B with respect to A. Velocity of B with respect to A. So the observer is in car A. So VBA is equal to VBG minus VBA. So VBG that is 8. Okay, 8 minus VBA, that is 2. That's equal to 6 meter per second. So when the observer is in the car A and he is watching the car B, so he feels that this car is at rest. When the observer is on this car is at rest. Okay. So the car B is coming towards this car at the rate of 6 meter per second. Okay, 6 meter per second. So VBA, then what is the relative distance between the car A and B? That is BA, that's equal to 24. Okay, so the relative, when the frame of reference changes, the relative distance between two bodies never change. Okay, so that is very, very important. That is the relative distance. So when these two cars are observed from the ground frame, the distance between the two cars is 24 meter. So now the frame of reference changes from ground to the car A. So still the distance between the two bodies is 24 meter only. Okay. So the relative, so velocity changes. Velocity is changing. So the relative velocity of B from the frame of reference, when the reference frame changes, the velocity changes, but the relative distance between two body never changes. Relative distance. Okay, relative distance between two bodies never changes. Okay, never changes to the frame of reference. So similarly, time also. Okay, time also does not change when the frame of reference changes. Okay, time. Okay, so the relative distance between two bodies is 24 meter. Now we have the velocity and distance. So we have to find the time. So time is equal to distance. Yes, distance by velocity. So that is 24 by 6. So that's equal to 4 seconds. 4 seconds. Okay, so we will get the same answer, that is in the previous method also we got that is 4 seconds. So after time 4 seconds the car B overtakes the car A. So the relative velocity concept, that is VBA. So the observer is on the car A and this car is at rest. So he watches the car B. So he feels that the car is coming, B is coming with the 6 meter per second. Okay, 6 meter per second towards the car B. So the relative distance between B and A is, that is 24 meters. So when the you have to keep in mind, that is the relative distance between two bodies never changes, that is does not change when the frame of reference changes. Frame of reference changes. So SBA is equal to 24. So T is equal to 24 by 6, that is equal to 4 seconds. Okay. So third question, second part. Okay, second part. So consider the situation. Consider the situation. It is 10 meter per second. So this is a car A. So that is 6 meter per second. Okay, 6 meter per second. So 96 meter. 96 meter. Okay, so a car A is moving with the 6 meter per second and another car is moving with, that is B is moving with the 10 meter per second in the same straight road and opposite direction. When they are 96 meter apart. Okay, 96 meter. When they are 96 meter apart. So find the time of collision. Find the time of collision. Find the time of collision. So we have to find at what time the two cars will collide each other. Okay, collide each other. So this case also, after time t. Okay, after time t the two cars will collide each other. So we are considering that after time t the two cars will collide each other. Okay. So the distance traveled by the car. So distance traveled by the car. Traveled by the car B in time t is equal to, that is velocity is equal to distance by time. So distance equal to velocity into time. The car is moving with 10 meter per second, that is 10t. Am I right? So similarly, distance traveled by the car A in time t is equal to, that is 60. Okay, 60. So the total distance traveled by the car in time t is, that is 10t plus 60. So the in between the distance, that is the two cars, the distance is 96 meter. In time t, the total distance traveled by the car 10t plus 60. So if this total distance equal to 96 meter, if the total distance traveled by the two cars in time t is equal to 96 meter, means the two cars will collide each other. So that is the condition. So 10t plus 60 is equal to 96. Okay, that is 16t is equal to 96. So t is equal to 96 by 16. That's equal to 6 seconds. Okay, 6 seconds. So we consider that is after time t, the two cars will collide each other. Okay, so the distance traveled by the car in time t is, that is 10t. So the distance traveled by this car in time t is, that is 60. Okay, 60. So the total distance traveled by the two cars is 10t plus 60. If this total distance so that is the condition. If this total distance 10t plus 60 greater than or equal to this 96, means collision happens. Okay, collision happens. If 10t plus 60 less than 96, means this distance, means collision does not happen. Okay, does not happen. So that is a condition we are using. Okay, so this is the normal method of solving this problem. So we have to solve this problem, the same problem, using relative velocity concept. Okay, relative velocity concept. ठीक है, relative velocity concept. So velocity of these speeds, that is 6 meter per second and 10 meter per second, means the velocity of these two cars when observed from the ground frame. I'm right, ground frame. So velocity of A with respect to G, that is equal to 6 meter per second. Velocity of B with respect to ground frame is, that is 10 meter per second. Okay, so now I am finding that is the relative velocity of A as seen by B, or velocity of B as seen by A. That is, A is the observer. Am I right? A is the observer, so which is at rest. Okay, VB. So that's equal to formula VBG minus VBA. So that's equal to VB that is equal to 10 minus of, because initially I told that is the objects which are moving in the leftward direction, that is the positive of the velocity of the objects moving in the rightward direction is taken as positive. The velocity of the objects which is moving in the leftward direction is taken as negative. So 10 minus, this is moving in the leftward direction, so minus of minus 6. Okay, so that's equal to 10 plus 6, so that is 16 meter per second. Okay, so what is the field? So now the observer is on the car A and he is observing, okay, observing the car B. So he feels that so the car B is moving with, this car is at rest only. Okay, now so the car B is moving with 16 meter per second towards the car A, So what is the relative distance between the car A and B? That is 96 meter. The relative distance between two objects never changes. When the frame of reference changes, the relative distance never changes. Okay, so now the car is coming with 16 meter per second. So the distance 96 meters. So we have to find the time. So AB is equal to, that is 96 meters. So we have to find the time to cover this distance. Okay, so T is equal to distance by velocity, distance by SAB by VBA. So that's equal to 96 by 16. Okay, so that's equal to 6 seconds. So we get the same answer that is in the previous method, that is 6 seconds. Okay, so the time taken two cars to collide each other is, that is 6 seconds. Okay. So fourth problem. Two trains A and B is coming in the same track, okay, opposite to each other. When they are headed each other at a distance of 2 kilometer, okay, 2 kilometer, both the drivers applied the brakes, okay, which causes the same deceleration or retardation in the two trains, that is of at the rate of 0.15 meter per second square. Okay, so we have to find whether the collision will take place or not. So once again I will tell the question. Two trains A and B which is moving in the same track at the rate of 54 kilometer per hour and 72 kilometer per hour. One train A is moving with 54 kilometer per hour and another train B is moving with 72 kilometer per hour. Okay. So when they are headed towards each other at the distance of 2 kilometer, okay, 2 kilometer, both the drivers applied the brakes, okay, which causes the deceleration or retardation in the two trains at the rate of 0.15 meter per second square. Okay, so we have to find whether the collision will take place or not. Okay, that's the question. So let us visualize the situation. You will understand more. Let us visualize the situation. Okay. A train A is moving with, that is a 54 kph, kilometer per hour. Okay, so another train in the same track, another train B which is moving with, that is 72 kph. Okay, kph. When they are headed each other at the distance of 2 kilometer. Both the drivers applied the brakes, okay, in order to avoid the collision, okay, or accident, they applied the brakes, which causes the deceleration at the rate of in each train, that is 0.15 meter per second square. Okay, so the same deceleration, so this train also at the rate of 0.15 meter per second square. Okay, so we have to find whether the two trains collide each other or not. Okay, so we have to find it. So solution, velocity of A with respect to, actually these speeds, the two trains are moving with respect to the ground frame. Okay, ground frame. So velocity of A with respect to ground is equal to, that is 54 kph. Okay, 54 kph. So 54 into 5 by 18. Am I right? 54 into kilometer per hour converted to meter per second. 54 into 5 by 8. So 3 times. So 3 into 5, that is 15 meter per second. 15 meter per second. Velocity of B with respect to ground, okay, velocity of B with respect to ground, that is 72 kph. So 72 into 5 by 18. So 4 times, that's equal to 20 meter per second. Okay, that's equal to 20 meter per second. So velocity of the train A with respect to ground, that's equal to 15 meter per second, and velocity of the train B with respect to ground is 72 meter per second. So acceleration of A with respect to ground, acceleration of the train A with respect to ground is, that is 0.15 meter per second square. Acceleration of the train B with respect to ground is 0.15 meter per second square. Okay, second square. So velocity of the train A as seen by B, velocity of the train A as seen by B is equal to VAG minus VBG. So that's equal to VA, that is 15 minus, so this is in the leftward direction, so minus of 20, so that's equal to 35 meter per second. Okay, 35 meter per second. Velocity of A as seen by B. So B is the observer. Okay, B is the observer. So this train is at rest. Okay. Then similarly, acceleration of A as seen by B is equal to acceleration of A with respect to ground minus acceleration of B with respect to ground. So that's equal to acceleration, so A in this direction, so leftward direction, so minus 0.15, so minus of in this rightward direction, so 0.15, so that's equal to minus 0.3 meter per second square. Okay, second square. Now what is the field? So now this train B is at rest, am I right? B is at rest. The train A is coming towards the train with the speed of 35 meter per second with the deceleration of 0.3 meter per second square. So understand the situation. Okay, now this train is at rest. This train is at rest. The train A is coming towards the train with the speed of 35 meter per second with the deceleration of 0.3 meter per second square. So deceleration happens means, so when the body, when the object goes on, the speed decreases continuously, decreases, and finally this object comes to rest. Okay, comes to rest. Okay, if a body is moving with the acceleration means speed increases as the object moves on, that is speed increases. Okay, so the body is moving with the deceleration means speed continuously decreases, and after a particular time, definite time, that is the object comes to rest. Okay, comes to rest. So we are going to find at what distance the object comes to rest. Okay, at what distance train A comes to rest, we have to find it. Okay, so if that distance is greater than or equal to this 2 kilometer means collision happens, accident happens. If that distance, stopping distance, is less than this distance, 2 kilometer means we can avoid the accident or collision. Okay, you understand that? So this train is at rest, B train is at rest. Okay, so because the observer is on the train B, it is at rest. So he is watching the train A. So the train A is coming with the speed that is 35 meter per second towards the train B. Okay, towards the train B with the speed 35 meter per second with the deceleration of 0.3 meter per second square. So if the object is moving with the deceleration, means continuously the speed decreases, and finally the train A comes to rest. Okay, comes to rest. So we have to find at what distance the train A comes to rest. So if the stopping distance is greater than or equal to this 2 kilometer, means collision or accident happens. If this stopping distance is less than this 2 kilometer, means we can avoid the collision. So how we can find the that is stopping distance? I am using the equation v square minus u square is equal to 2as. Okay, the stopping distance, finally the train A comes to rest, so the final velocity is 0. Initial velocity, the train is moving with the initial velocity, that is 35 square is equal to 2 into, that is a deceleration, minus 0.3 into s. Okay, yes. So this minus cancel. So s is equal to 35 square divided by 2 into 0.3. So that's equal to, that is when you solve this 35 square into 2 into 0.3, you solve this, that is you will get 2041.66 meter. Okay, 2041.66 meter. So initially that is this is 2 kilometer. 2 kilometer means it is 2000 meter. Okay, the train comes to rest after traveling 2041.66 meter. So which is greater than this distance. Okay, so 2041.66 is greater than 2000. So the train comes to rest, the train A comes to rest after traveling 2041.66 meter only. So which is greater than this 2 kilometer, because initially the trains are at a distance of 2 kilometer only. So the train must collide each other or accident happens, must happen. So the accident must happen. Okay, must happen. So that is the conclusion. So we have to find whether the two trains collide each other or not. So the trains must collide each other. That is the conclusion. The trains must collide each other. Okay. Clear? Then fifth question. Two parallel rail tracks run north-south. Train A moves north with a speed of 54 km per hour and train B moves south with a speed of 90 km per hour. So what is 1. Relative velocity of B with respect to A, relative velocity of an observer in the ground with respect to B. Third, velocity of a monkey running on the roof of the train A against its motion, that is with a velocity of 18 km per hour with respect to the train A, as observed by a man standing on the ground. So this is the question. Okay, let us visualize the question, you will understand more. Let us visualize the question. So before that, so this direction we will take it as north and it is positive. This direction we will take it as south, that is taken as negative. Okay. So two trains is here. So it is moving with that is 54 kph. Okay, 54 kph. So another train in the same parallel track B, which is moving in the southward direction, that is 90 kph. Okay, 90 kph. This is the platform. There is one observer. Yes. Okay. Yes. So there is a monkey in the top of the train A. Top of the train A, which is moving with the, so with respect to the train A, which is moving with, that is 18 kph in the against the motion of the train. So this is the visualization of the question. A train A is moving in the track which is moving in the northward direction with the speed of 54 kph. Another train in the parallel track which is moving in the southward direction which is moving with the 90 kph. Okay, so in the ground that is an observer is there. Yes. Top of the train A, monkey is running against the motion of the train. It is given in the question, against the motion of the train, that is with respect to this train. With respect to this train, the monkey is moving with the 18 kph. Okay, 18 kph. So we have to find, so what are the things we have to find? One, velocity of A with respect to B. First thing we have to find velocity of A with respect to B in the question. So from this we can write velocity of, so these are the speeds A and B speeds are with respect to the ground only. So the velocity of the train and the velocity of the train B is in the with respect to the ground frame. So this speed 18 kph is with respect to this train only. Okay, with respect to this train only. So velocity of the train A with respect to ground. So we can write VAG is equal to, that is 54. Okay, 54 kph. So 54 into 5 by 18. Am I right? 5 by 18. So 3 times. So 15 meter per second. VBG with respect to ground is equal to, that is 90 kph is equal to 90 into 5 by 18. Okay, so 5 times, that's equal to 25. Okay, 25 meter per second. So first we have to find, first in the question, first we have to find velocity of A with respect to B. Velocity of A with respect to B is equal to VAG minus VBG. Velocity of A with respect to B. So that's equal to VAG, that is 15. Okay, minus, so in this direction, that is northward direction, towards north is taken as positive. So A is moving towards north, so positive. So towards south is taken as negative. So minus 25. So that's equal to 40 meter per second. 40 meter per second. So what is the field? Velocity of A with respect to B. So an observer an observer is sitting in the train B and he is watching the train A. So what he feel? So he feels that the train A is moving towards north. Okay, this is positive. So train A is moving towards north at the speed of 40 meter per second. Okay, 40 meter per second. Next. So second thing we have to find in the question, it is asked, that is velocity of the observer, in the ground, with respect to B. Okay, with respect to B. So a stationary observer is in the platform or in the ground. Okay, yes, we have to find the velocity of this observer with respect to this train B. So the velocity of the observer with respect to ground is 0. So a stationary observer is standing on the ground. Okay, ground. So we have to find the velocity of that observer in the ground with respect to the train B. Okay. That is velocity of the observer, yes, with respect to the train B. So that's equal to VSG minus VBG. Okay, so VSG, that is 0, minus of VBG, that is it is moving in the southward direction. Okay, southward direction, so minus 25. So that's equal to plus 25 meter per second. So what is the field? So when an observer is in the train B, and he looks outside the observer, in the platform. Okay, looks outside the man in the platform. Okay, in the platform. So he feels that the man is moving, so positive, that is plus 25. The man is moving with the speed of 25 meter per second towards north. Okay, towards north. So towards north is taken as positive, towards the south is taken as negative. Here plus 25. So a passenger in the train, feels that the man in the platform, yes, is moving with the speed of 25 meter per second towards north. Okay, towards north. Then the third thing we have to find, so velocity of the monkey as seen by the observer. Okay, velocity of the monkey velocity of the monkey as seen by this observer. Yes. Okay, velocity of the monkey as seen by observer. Yes. So actually the monkey is moving on the top of the train with a speed of 18 kph with respect to the train A, not the ground, with respect to this train 18 kph. Okay, so that what is the meaning? That is when a passenger inside the train watches, the monkey is moving with 18 kph, kilometer per hour, against the motion of the train. Okay, with respect to this train. Okay, so we have to find the velocity of the monkey as seen by velocity of the monkey with respect to this observer we have to find. So velocity of the monkey with respect to is equal to, what is the formula? That is velocity of the monkey with respect to ground minus velocity of the observer with respect to ground. Okay, so velocity of the monkey with respect to ground we don't know. Velocity of the monkey, am I right? So velocity of the monkey with respect to the ground we don't. So in the question it is asked, that is velocity of the monkey as seen by s, that is velocity of the monkey with respect to s. Okay, so formula, that is velocity of the monkey with respect to ground minus velocity of the s with respect to ground. So but velocity of the monkey with respect to ground we don't know. So it is 18 kph velocity of the monkey with respect to the train. Okay, so what is given in the question, that is velocity of the monkey with respect to the train, with respect to the train A is given. Okay, VMA is given. Okay, is VMA is given, that is minus 18, because it is against the motion of the train, that is in the southward direction, so minus. So 18 kph. Okay, 18 kph. So that's equal to 18 into 5 by 18. So that's minus 5 meter per second. So minus 5 meter per second. Now VMA, how we can write, that is velocity of the monkey with respect to A. We can write, so velocity of the monkey with respect to ground minus velocity of A with respect to ground. Okay. So VMA, so VMS we are writing, that is velocity of monkey with respect to ground minus VSG. So similarly VMA, so velocity of A with respect to yes, VMA we can write velocity of monkey with respect to ground minus velocity of A with respect to ground. So that's equal to minus 5. Minus 5. So from this we can find, that is VMG. Okay. So VMG is equal to minus 5 plus VAG. Okay, VAG. Am I right? So VMG is equal to minus 5 plus VAG. So that's equal to minus 5 plus, what is VAG? So that is 15 meters. So 15. So that's equal to 10 meter per second. Now we can find, that is velocity of the monkey with respect to the observer S. Okay, with the observer. So VMS equal to VMG is equal to, yes, VMG is equal to, that is minus 5, that's equal to minus 5 plus VAG, that is 15. So that's equal to 10 meter per second. Okay, so now VMS equal to, so velocity of the monkey with respect to the observer S, that's equal to VMG. What is VMG? So this is VMG. This is VMG. Okay? VMG. So VMG is equal to 10 minus VSG, that is 0. So that's equal to 10 meter per second. So positive direction. Okay, positive direction. So what you will feel, that is 10 meter per second, that is positive. So the observer feels that the monkey is moving in the northward direction. So the monkey is moving with 10 meter per second in the northward direction. Okay, northward direction. Okay. So clear? So the three things we have to find, that is first one is the velocity of A with respect to B, second one velocity of the observer with respect to the train B, third thing, that is velocity of the monkey with respect to the observer. So that's equal to 10 meter per second. So with this I wind up this session, that is the 5 problems in relative velocity. So another 5 problems we will discuss in the next section. So it includes the police thief problem, okay, police thief problem, and that is motion under gravity, okay, motion under gravity with relative velocity. So how to solve the problems of motion under gravity? So we have already discussed the problems of motion under gravity. So how to solve some of the problems in motion under gravity using relative velocity concept that we will discuss in the next section. So another 5 problems in relative velocity we will discuss in the next section. So stay tuned. Bye.